Hello, in this video, we will learn how to solve any sum of series program in Java. Now there are so many different types of series and so many programs on them. How do you learn so many of them? You do not need to. What we are going to do is to understand how to solve a few basic types of series and then how to combine them to handle any complex series. Let's start by first looking at few series and see what are some common things you need to do to build a template which you can use for all different types of series. We will start our template by including utils library and writing the main function. Next thing you need to do is to declare a variable to hold the sum value. Here you have to see in the question if there are integer values getting added or double values and accordingly declare the sum variable type. If there is any division in the term or any decimal value function like square root, etc., in all such cases the sum will be declared double. Right now I will use int, but you know the alternate option for this is double. Now in most of the sum of series program, you have to find sum of n terms. Like for example, in this series, n can have value of 5, means 5 terms need to get added. Or here n can take value 4, means 4 terms of the series need to get added. This n is usually taken in from the user, or it might be provided in the question itself, like in 4th series over here. You can see 10 terms are getting added. So we can use scanner class to take in the value from the user, or if it is given in the question, assign it to n directly. In some of the questions, you will see another variable x, and in those programs, you have to take that too from the user. Mostly this is to int. Now in this sum variable, we have to add each term of the series one by one, so we will have to set up a loop. How will we set up this loop? We will set up a loop from I is equal to 1 to I less than and equal to n. You can also set up this loop from 0 to less than n if you are comfortable working with 0. Idea is to make sure the loop runs n times. Some very important point over here. When you are setting up the loop, first is the number which you use to initialize I. Do not confuse this number with the starting number of the series. For example, here the series is not from 4 or x or 2. They are only the first number of the series. Similarly, do not confuse n with the last number of the series. N is the number of terms that is to be added, not necessarily the last number of the series. It may or may not match. Within the loop, we will do the actual work to calculate the sum. To the sum, we will add each term every time, which we will learn how to make in this video. Outside the loop, we will just print the sum value. We will use this template now to solve all our series program. Now let's look at some basic series and see how to solve them. First basic type of series is arithmetic series, like these. Why are they called arithmetic series? That is because each term is getting incremented by a fixed number. Like the first one is getting incremented by 1, second is getting incremented by 4, third and fourth are getting incremented by 2, and last one is getting decremented by 1. To solve any of these, we will first follow the template we listed above. Within the main, we will declare the sum variable and set the data type of sum properly by looking at the series. Here we see all can be int. We will initialize it to 0. Next, we will input the value of n from the user. You can use scanner class or anything else you are comfortable with. For the fifth, since we know n is 10, we will just directly assign n is equal to 10. Next we will set up the loop. For all of them, the loop is from 1 to less than equal to n. Inside the loop, we will just add the term to sum every time. Outside the loop, we will write the print statement to print the sum. Now let's learn the key part, how to find the sum of these series. Let's start with the first one. In this we are adding 1 with 2 and then 3, 4 till n. Now if you know a little bit of coding and indexing, you might figure out that index I is actually already taking on values from 1 to n in this loop, and you can actually solve this by just writing sum is equal to sum plus I in the loop, and you are done. Actually, most of the series can be solved by using the index itself. However, I see many of the kids get confused in using I initially at least, so for newcomers, I recommend always use another variable. So the job of I is only to run the loop n times so that we can add n terms of the series. We will use a new variable a to form individual term of our series. This a will have initial value of whatever is the starting number of the series. Like in this case, it is 1. Then we check what is the number getting incremented by. Here it is getting incremented by 1. So we will add a++ to the for loop. What this is doing is that when the loop starts, it is initializing a to first member of the series and then incrementing it by 1 every iteration. Inside the loop, then we will just add a to sum every time. This completes the first series program. Now what if we were doing the second series 9, 13, 17 till n? How does this program change? This time we will assign 9 to a and then just do a plus is equal to 4 in the loop. Now for every iteration, a will get incremented by 4 as per the term of the series and get added to sum. This solves this series program. Let's see the next one. Here starting number is 2 and it is incremented by 2. So we will just set a is equal to 2 and increment it by 2 every time. This is the program for this series. Now for the next series, the starting number is 1 and it is incremented by 2 every time. So we will just change the starting number to 1. And this solves this series. Let's see the next series. Here there are decreasing numbers, so we will set the initial value of a to 10 and then do a minus minus every iteration. This is the program for this series. Now this sounded so simple, but you might say the series which I get to solve look way more complex. Something like these. If you look carefully, all of them are arithmetic series, just that each term is presented in a bit complex way. All we need to do is now build each term as given in the question. Let's see how we will write the program for these. We will start with our standard template, and after main, first thing we will declare is the variable sum. As you see, all of them have either power or division. So we will play safe and declare sum as double. Some of them have an additional variable x. So along with n, we will also take in x from the user. We will write our basic for loop from 1 to n. Inside the loop, we will write sum is equal to sum plus term. Outside the loop, we will print sum. Now our template is ready. We will see how to form each term to add to sum. In the first series, we see that the power number is an arithmetic series starting from 1 and incrementing by 1. So what we will do is first just add another variable a to for loop and initialize it to the first number of the series, which is 1, and then add a++ to the loop. Then inside the loop, we will create individual term and write sum is equal to sum plus math.pow x comma a. So this is the same series and we have just matched the term to as given in the question and we get the program. Now let's solve the next one. This requires only taking n from the user. Here each member of the arithmetic series is raised to the power of 2. So in our for loop, we will first initialize a to first member of the series and then do a plus is equal to 4 for each iteration. In the sum, we will just change the statement to sum is equal to sum plus math.pow a comma 2, or you could just write sum is equal to sum plus a into a as given in the question. This gives us the program for this series. Let's solve the next one. Here we know n is 10, so we will directly assign n is equal to 10. In the for loop, we will assign a the first number of the series, which is 2, and do a plus is equal to 2 in each iteration. Inside the loop, we will form the term of the series by just doing sum is equal to sum plus math.pow a comma x. This is our program for this series. Now let's see next one. Here we taken both n and x from the user. For the arithmetic series, we will just initialize a with 1, which is the first member of the series, and then increment it by 2 in every iteration. Inside the loop, we will now write each term as sum is equal to sum plus math.pow a comma 3 divided by x. Please note, in each of our programs, our expression matches the series term exactly. Luckily for us here, math.pow returns double. If instead of using pow function, you would have written a multiplied by a multiplied by a divided by x, then it would have been int divided by int and it would have truncated the decimal value. In such scenarios, you have to at least typecast numerator or denominator to double. Even if one of them is double, it converts the whole equation to double. Let's move to next program. Now this is an interesting one. It has two series. Numerator has a different series and denominator has different series. How do we solve this one? It is equally easy. Here we know n is 10. In the for loop, we will now take two variables. First a for numerator and assign it to 2 and do a plus is equal to 2 for each iteration. We will take another variable, let's say d for denominator, and assign it to 10 and then just decrement it at each iteration. Inside the loop, we will just do sum is equal to sum plus a divided by d. Here I want to pause and tell one important point whenever you are doing division. Here there is one error. There is division of int divided by int and it will truncate the decimal value. In a division, at least one of the variables has to be double, otherwise it will do integer division and truncate the decimal value. So I will just typecast one of them to double. This gives us the program for this series. Using this logic, you should be able to solve any series which uses arithmetic progression. Now let's see another simple series, geometric progression, like these. Why are they called geometric series? That is because every new number is derived by multiplying the previous number by a fixed number. Like the first one is getting multiplied by 2, second and third are multiplied by 3, and fourth is getting multiplied by 5, and so on. To solve any of these, we will first create our template as we discussed earlier. We will write the main and we will declare the sum variable and set the data type of sum properly by looking at the series. Here all can be int. We will initialize it to 0. Next we will input the value of n from the user. Now we will set up the loop. For all of them, the loop is from 1 to less than equal to n. We will add individual term to sum inside the loop. Outside the loop, we will write the print statement to print the sum. Now that we have our template ready, let's learn the key part, how to write the sum of these series. Let's start with the first one. Here starting number is 2 and next number is obtained by multiplying the first number by 2. So in this case, we will assign k to 2, which is the initial number, and then what we do is k multiplied by 2 for every iteration. Now this will every time multiply the previous number by 2. Inside the loop, we will just add k to sum for each iteration. So if a user enters n is equal to 5, the loop will run 5 times and k will start with 2. Then it will get multiplied by 2 to 4, then 8, then 16 and 32. Every time it will get added to sum. And this is our program for the series. Let's look at the next series. We again start with our standard template. In this we assign k to 2, which is our first number of the series. Then we will just do k multiplied by 3 for every iteration. Inside the loop, we will just do sum is equal to sum plus k. This is our program for second series. Similarly, we will solve the next series. In the template, we will assign k to 10 in the for loop and then do k multiplied by 3 and do sum is equal to sum plus k inside the loop. This is the program for the third series. Last one is also similar. We will assign k to 5, which is the first member in the series. We will then do k multiplied by 5 for each iteration and do sum is equal to sum plus k inside the loop. This is the program for the last series. Now this sounded so simple. You might say the series which I get to solve look way more complex, something like these. Let's see how we will write the program for these. We will again start with our standard template. In main, first thing we will declare is variable sum. As you see, most of them here have division except for the second one, so we will declare our sum as double. Some of them have an additional variable x, so along with n, we will also take x from the user. We will write our basic for loop from 1 to n. We will add term to sum inside the loop and outside the loop we will print sum. Now our template is ready and we will see how to solve the series. Let's start with the first one. This has a geometric series in the numerator, so in our for loop we will add variable k and initialize it to first number of the series, which is 2, and then add k multiplied by 2 to the for loop. Then inside the loop we will write sum is equal to sum plus x divided by k. So this is the same series and we just change the individual term and we get the program. Since there is division, we will make sure to typecast either numerator or denominator to double. Let's solve the next one. In this we can have sum defined as integer and we take in only n from the user. But it has one thing different, which is that alternate numbers of the series are negative. I will show you how you will solve this and you can apply the same logic for any series with alternate negative number. So we start with our template and in our for loop we initialize k to 2 and add k multiplied by 3 for each iteration. Now if you look at the series closely, you will see that the number at odd positions are positive and number at even positions are negative. So what we will just do is that inside the for loop, we will just check if I is even or odd. If it is even, we will subtract from sum. If it is odd, we will add as usual. This is the code for alternate sum and subtraction, and this logic can be used for any series. Let's solve the next one. Now this one has two series. One is arithmetic series in the numerator and geometric series in the denominator. How do we solve this? We will start with our template, and what we will do is that we will take two variables in the for loop. One a, which we will initialize to 2, and k, which we will initialize to 10. We will add a plus is equal to 2 for the arithmetic series and k multiply equal to 3 for the geometric series. Inside the loop, we will just do sum is equal to sum plus x plus a divided by k. Two very important things you need to remember here. Many of my students in a hurry to solve this forget to put the brackets. If you forget it, you will get completely different answer. So always remember to use brackets when there is division. Second thing is, since x, a and k are all int, this will result in integer division as we discussed earlier. You have to typecast either numerator or denominator to double. This is our program to solve this series. Let's now solve the last one. This has 3 numbers and potentially 3 series. Let's take our template and try to solve it. In numerator, we have a geometric series, so in for loop, we will add k is equal to 5 and k multiplied by equal to 5 for each iteration. In numerator, we have arithmetic series, so we can add two variables a1 and a2. a1 we will initialize to 1 and a2 we will initialize to 2. We will just add a1 plus plus and a2 plus plus for each iteration. Inside the for loop, then we will form this expression and we will write sum is equal to sum plus x into math.pow k, 2 divided by a1 plus a2. Here again, do not forget the brackets. Since math.pow returns double, we do not need to initialize to double here. Now this answer is technically right, but after doing many series program, you will understand we have been using redundant variables. I am going to explain it here. However, if you do not get it, please continue using extra variable and get the program right. If you closely look at this equation, the second number in denominator can also be written as first number plus 1, or a2 is actually nothing but a1 plus 1. So you do not need to declare a2. You can actually write a1 plus 1 or 2 into a1 plus 1 over here and get the same answer. If you actually take another closer look, both I and a1 are actually doing the same thing. They are initialized by 1 and increment by 1 for each iteration. So actually you do not need a1 too. You can easily substitute I for a1 and your equation would look something like this. If you are understanding this concept, you will find that at many of the programs which you have solved earlier, you can make the separate variable redundant and just use I. You might not get this concept now, but after you have practiced a few programs, you will definitely get hang of this. If you are still finding it difficult to understand, you can reach out to us at simplycoding.in. In our next video, we will learn how to solve more series programs which require nested loops like series with factorials. Thank you and goodbye.